We are going to be doing variation story problems in this lesson. So the first one is the amount of a person's paycheck, P. So I'm going to kind of write the equation as I go. P is directly, so that means you're going to have a constant and your variable would go next to it. P is directly proportional to the number of hours worked. So this is going to be your basic function. And then it says, when you work 17 hours, you get paid $90.10. So clearly, you need to get, however much you get paid is dependent on however many hours you work. And the problem is you don't really know how much per hour you make here. So you have to figure out what that constant is. And in this case, that constant is going to tell you how many hours or how much money you get per hour of working. Okay? So in this case, you will plug in $90.10 equals K times 17, divide by 17, and K will be $5.30. That's very cheap. And so then the question is, at that same rate of pay, at that same constant, what will you get paid for 25 hours of pay? So your pay will be $5.30 per hour times your 25 hours, which of course makes $132.50 is what you would get paid according to this equation. All right, next, the price of a person, the price per person of renting a bus varies inversely. So I didn't give you variables here, so we'll say that this is price varies inversely, and that means when it's inversely, that number or that variable has to go in the denominator. So it varies inversely with the number of people renting the bus. So, and that makes sense. The more people that rent a bus, the cheaper it is going to be per person. Okay? So, here you go. You're going to plug your pay in and you'll go from here. So it's $13 per person if 66 people rent it. So I will plug it in like that. So again, P is the price per person, N is the number of people on the bus. So I will multiply by 66, and K will be $858. Basically that means that the bus costs $858 no matter how many people you have on it. Okay? Now, if you're wanting to put 94 people on that bus instead, then what you will do is you will go back to that parent function, and I don't know the price per person, but I know that the cost to rent the bus is $858, and I am going to put 94 people on it. And when I take 858 divided by 94, the price comes out to be $9.13 per person. So that is much cheaper. Okay, and lastly, the amount of oil, so I'm going to call that O, used by a ship traveling at a uniform speed varies jointly, I'm going to put my K in there, varies jointly, so that means I have more than one variable and they're both going to be on top. Varies jointly with the distance, which I will call D, and the square of the speed, which I will call S squared. And sometimes it might say it varies directly as the distance and inversely as the square of the speed. If it said that, just so you know, because that might come up in accelerated math, if it varies directly as the distance, the D goes there, and inversely as the square of the speed, that's what it would look like. Okay? And that may come up in your accelerated math, just so you know. But here's our parent function. And it says if the ship uses 400 barrels of oil, so I will put the 400 in for my O. I do not know my K. I know that it is traveling at 500 miles, or for 500 miles, at 40 miles an hour, and I need to square that number. Okay, so then when I multiply that out, 500 times 40 squared gives me 800,000. And I will divide by my 800,000. And K comes out to be 0.0005. Okay. And then, of course, I will plug this back in. So now my new equation becomes 0.0005 d s squared, because that's what my K value is. And now I want to know if I travel for 400 miles at 20 miles an hour. So I will take 0.0005 for 400 miles times my speed squared, and I will do that, and it will take me 80 barrels of oil to do that.